This is the first session for the course Statistics in R. This course is for people who are new to R programming language and they want to learn how to apply statistics using R. So, in this session, we are going to cover some of the basics of R. I'm going to give you the list. So first of all, we will talk about a bit compiler and interpreter. I'm not going to go in depth for these. I just want you to know the basic difference. Then we will move to R language. I will provide a brief introduction on the R Studio interface. Then we will discuss data types in R, how to print a value using print function. Then we will see the concept of variable, why we need variable, and how can we create one. Then we will see basic arithmetic operations such as addition, deletion, subtraction, multiplication. And then we will write our first R script. And at the end, I will try to include an introduction on the data structure of vector. So let's start our session. So first we will talk about what is compiler and what is interpreter and how these programming language actually works. So in the beginning, computer used to work only on binary. So this is also the case at the current moment. Computer understand only binary code. Now, in the beginning, there was no language available at the moment. Therefore, people who are expert in those codes, they used to write program in those instructions, and that's the reason why were a limited set of people who had the access to computer, because it required a lot of expertise on those instruction. And here I am trying to give an example. This is a very basic example. So let's say I want to add two numbers. Now if I consider the initial scenario where computer understand only binary and we don't have access to any language, so in that case I have to write the instruction in the machine code, and by that I mean binary code. So in binary, everything is represented by 0 and 1. So I will write something like this one. So first uh, binary code represent what operation I want to perform. So this is not necessarily representing addition. This is just for illustration. So first I will specify the code for instruction I want to perform, and then I specify the operands on which I want to perform this instruction. So I want to add two numbers. I specify the uh, instruction or operator. So I want to perform addition, and these are the numbers on which I want to perform the addition. So this was the case in the beginning, and then people realized that it is a bit difficult to remember all these codes and writing program in such a way. Then what they did, they replaced these instruction code with that text representation. So for human, it's a bit easier to remember text than numbers. So for instance, instead of writing now the instruction code, they can write directly the text. For instance, add for addition, sub for subtraction. And then so they write the code like what instruction they want to perform, and then the operands. And in this code, the operands were used to be specified in hexadecimal. So we are not going to go in depth. Just for illustration, we are thinking how we were making it easier, how the people made it easier to program. So now, as you can see, if you are writing a code something in this format, and in order to execute that code, this program or this instruction has to go under some conversion, because computer understand only binary and you are writing here text or hexadecimal. So there has to be some mechanism to convert this code into machine code, and the program which was responsible for that known as assembler. Now just go a bit further. So at the moment we are having a different programming language. So what they do, they simplify the process, this program writing much easier. So for instance, in R, if I want to add two number, I will simply write the number operator and the number. So here the binary which I have used, this is the binary equivalent of 160 and 104. And in R, I will simply write 160 plus 104. Now the thing is, computer again cannot understand this one. Then there has to be some mechanism which can convert this instruction into a binary. And here comes the role of compiler and interpreter. So there are two different ways to convert your code into a machine understandable code. And just for the information, if we add two number in R, the equivalent instructions in assembly look like this one. So this one instruction, just for illustration, in actual we need to write a bit more instructions just to add two numbers. Now you can see the abstraction we got from assembly to programming language such as C, C++, R, Python. So we are writing program in R, and in order to execute that program has to be converted into machine code, and the program and actually the component who is responsible for that conversion, it could be compiler or it could be interpreter. Now we will see the difference between these two. So first we will look at compiler. What is compiler? So let's say we have written a program. So program means a set of instructions to do a task. And there are multiple instructions in this program. Now what compiler does? Compiler convert entire program into a machine code and save that file. So the entire program is converted into machine code, and once we have this machine code of entire program, then this entire machine code will be given to the computer for execution. Okay, now what happens in case of interpreter? So let's say we are having a similar program in another language. So these are the set of instructions, and what an interpreter will do, the interpreter will take instruction by instruction. So interpreter will take first instruction, and this instruction is executed. Now how this execution is done? This instruction is converted into machine code, and that machine code is directly given to the machine for execution. So as you can see, there is no saving in between. So interpreter execute instruction by instruction. So once the first instruction is executed, then interpreter will take the second instruction, then third, and so on. So this is the difference between compiler and interpreter. Interpreter take instruction by instruction, convert those instruction, and without saving the machine code of that particular instruction, it directly execute them. Now in compiler will take entire program, will convert that program into machine code in its entirety, and once the conversion is done, that machine code is executed by the computer or machine. So this is just a basic difference, and we are not going for a further comparison. This is just to give you an idea. When we say a language is interpreted or when a language is compiled, in that case you can understand the differences. So for the information, R is an interpreted language. In that case, when we write instruction in R, interpreter execute one by one. So now we will move to our R Studio interface, where I will give you a brief introduction about this interface. So this is the R Studio, what it looks like. So here we are having multiple portion. So if you can see, this entire window is divided into multiple portions. So this one we will call it console, and here we can execute our instruction or our commands. Now we are having one portion here. So this portion is actually used for plotting your graphs. So if you are making a graph, that graph will be visualized here. You can see the available packages of R, which we will see how to use that. And the most important part, you can have access to help to R functions. So if you don't remember a syntax for a particular function, you can simply write that function here and it will give you the help. And this area will show you the current saved variable in the environment, and it will also allow you to import data sets. So this is the uh, brief introduction about the R Studio, and we will learn about it in details as we write our programs or commands here. Now, after R Studio introduction, the next part, so we are going to start with data types in R, and there are different data types, and we will see why R needs those data types, and how we can find out whether a value is a numeric data type or character data type or other. So as we have already talked about, that computer only understand binary, and when we have different type of data, R takes that data differently to store that in memory. For instance, if we have numbers, those numbers will be directly converted into binary, and that then binary is stored in the memory. If we have character, or if we have a string type of data, for instance address or name, then it has to be first converted into integer, and then it has to be saved in memory. So we will see one by one. So the first data type we are going to see is numeric. So when you write any number and we want to see what type of data type is this one, so you can write class and then you write the value. So uh, I want to find out what's the data type of this value, like 12. So this is considered as numeric. I'm writing a decimal number. This is also considered as numeric. Now let me write a name. So I have written a name, and when I checked the data type, it showed me character. Let me write a single character. So that is also considered as character. So doesn't matter if you are specifying a single character or multiple characters, all those will be treated as character data type. And if you have noticed here, for character data type, I have enclosed the value in quotes. So you can either use single quote or you can use double quotes. The other data type we have is logical. And what does that mean? Sometimes we want to store a value as a true or false, especially when we evaluate a condition. The result of a condition is, let's say, true or false. So R has a data type for that. So if you will write if you will check the data type of true, it will show you logical. You can also just write the first letter, logical. Logical. So far we have seen three different data type: numeric, character, logical, and then we also have support for complex data types. So complex data type, where a imaginary value is also stored, and in R, imaginary value is represented by I. So let's say I'm having a value, a complex value, and I want to find out the data type of that value. So my value is 2 plus 3 iota. So this is the data type of complex. Now coming to the raw data type. So this is the data type which represent how the value is stored in the memory. So we are not going to deal with that data type. So we are going to mostly use numeric, character, or logical. So now as we are done with data types, numeric, character, logical, complex, and draw, we will move further. And now we will see arithmetic operators. Now if you want to clean your console, you can either click here or you can press Ctrl plus L. Now in arithmetic operator, just to make it simple, we will open the help for our operators. So just write plus sign and select it. It will show you help for your arithmetic operators. So as you can see here, we are having multiple types of arithmetic operators: addition, subtraction, multiplication, division, then exponent, modulus, integer division, and we will use it one by one. So let's say I want to add two numbers. So I can simply write this expression and your console will work as a calculator. I want to subtract 3 from 23. Subtraction is also working. I want to multiply. It's also working. I want to divide. It is also working. Now for division, we also have another operator which is represented by percent, uh, division sign, and then percent. And this is known as integer division. So to show the difference, I'm going to use the same expression but with a different division, with integer division. So as you can see the difference, integer division will not provide any value after decimal, whereas this normal division also give you a value after decimal if any. Then we have exponent. So for instance, I want to compute 2 to the power 3. So how can I write? I can write 2 exponent sign and power. So this is 8. Now let me take something else. 7 to the power 5. So you can apply exponent to get power of any number. And then we have modulus operator. So this operator will give you the remainder. So let's say if I divide 10 by 3 and I want to get the remainder. So if we divide 10 by 3, we will get a remainder of 1. So it will give you remainder 1. Now if you have noticed, with all these operators we have used two numbers, two operands, and that's why all these operators also called as binary operators. Now there are cases with addition and subtraction where it will also work with single operand. And so when we want to specify the sign of a number, let's say I want to say plus 20. So this is shown as a 20 because by default it is considered as a positive value. But if I want to have a value as minus 20, then this is considered as a value with a negative sign. So these are the arithmetic operators. And now we are going to print those value. Actually we are going to print in the next step. So far we have seen basic data types in R. So mostly we are going to use numeric, character, and logical. Then we have seen arithmetic operators: addition, subtraction, multiplication, division, exponent, modulus, and integer division. These operators are binary operator except plus and minus. They can also be used with a single operand, and that's why they are also a unary operator. And here in help you can also find the code which will help you to understand So we have seen the uses of these operators. Now we will move a bit further. So now we will talk about variable. What is a variable? So when we write a program, sometimes we want to store a value for a later use. For instance, let's say I'm having a data of employees or salary data of employee, and I want to count the number of employee who are having salary higher than the average salary. So what I will do, I will first find out the average of a average employee salary. I can store that number somewhere, and then I can compare that number with the all employee salary and can count the number of employees who are having salary higher than the average salary. Though in R we are having a simpler function. By calling those function we can get this value, but just for illustration I have used this example. So one of the use for variable is that one, if you want to use a value for later use. Another reason is that when you store something in a memory, that value is actually stored on a particular address. Now that address is actually in hexadecimal format or in binary format, and it's very difficult to remember. Now to simplify that process, when we create a variable, in a way we are saying that a value is stored in a memory, and that the value can be accessed by just by using the name which we have used. So I will give an example, then the things will become more easy to understand. So what I will going to do, first I will create a variable. So how you can create a variable, you can write the variable name, and then this is the assignment sign, and then the value you want to specify or you want to assign to that variable. So let's go to our RStudio console and create our first variable. So my variable name is x, and I'm storing a value 10 in x. So as you execute this instruction, you will see a variable in this area. Now in terms of memory, when we stored this value 10, this value is stored somewhere in the memory, and that memory has an address. Now instead of remembering that address, we can easily remember this name which we have assigned, which we have used as a variable. So by writing this instruction, we have said set x to 10. Now whenever we want to use this value, we will simply write the name of this variable. So we will simply write x. So if I will write x, it will give me the value which is stored in this variable. And you can also use print. So this function print the value of this variable, print x. So 10 is printed. Now let me create some other variable. Let's say I want to store a name. I want to print it. It will give me the value stored in this variable. I can also store true or false. And let's store a complex value. So this way you can create a variable. So the syntax is you specify the variable name and then assignment operator and then the value. Now coming to the name, what we can use for name. So you can use any letters or digit. You can also use period and underscore. Now there is a condition, your variable name has to be start with a letter or a period. And if it start with a period, it can not be followed by a digit. And the third is reserved word in R cannot be used as identifier. So I will give example for each of these points. So Variable name can be any sequence of letters, digit, underscore, or dot. So I will write a variable, let's say radius circle 123 dot first. So I have created one variable, and as you can see, I have used underscore, numbers, characters, and dot. Now I will try to create a variable by starting with underscore, and it gave an error, so unexpected input. So we cannot start a variable name by underscore. We can start a variable name with dot, so no problem with that. However, you will not see this variable in this list. It will be a hidden variable. Now we have seen what type of variable name we can specify. Now coming to the second point, if we are starting a variable with underscore and if we are starting a variable name with a period, then it has to be followed by a character. So if I am starting a variable name with dot, and if I follow it with underscore, then it will be a problem. Oh, sorry. So it's not underscore. After dot, you cannot use digit. So as it is given in this second point, sorry for the mistake. So if I will write a variable name starting from dot and then followed by a digit, then it will show an error. So the simple rule, you can use any character or digit or underscore and dot in your variable name. If you're starting your variable name with a period, don't use digit immediately after dot. And now what's the meaning of reserved words in R cannot be used as identifier? So in R there are some words which are reserved. For instance, as we have seen previously that there are values like true and false. So these words are already reserved, and if you try to create a variable with these name, let's say I want to create a variable with name true and I want to specify a value 12, so it will show an error to you. So these are the reserved words, and you cannot use reserved word for your as your variable name. So now we are done with how to create a variable, and now the time to write our first R script. And what we are going to do, we will write a simple script that will print addition of two numbers, subtraction, division, multiplication of those two numbers. So I will go to file, I will go to R script, and here I will write my first script. So I'm storing the number in variable A and variable B, and the result I will store in other variables. So as we have executed this expression already, so it will add two numbers. Now here we are saying add these two numbers and the result will be stored in another variable C. Then we will do the subtraction, we will do the multiplication, so we have created four more variables storing addition, subtraction, multiplication, and division. And now we will simply print those variables. Print C, print B, E. Save this script. So I will save this script, let's say first.r. So R script has extension .r. Now the question is how we are going to execute this script. So first let me clear my console. Now in order to execute this script, I need to simply click on source and this script will be executed. So these are the results from our script, and the result includes addition, subtraction, multiplication and division. Now what I want to do is instead of assigning these simple values, I want to take input from the user. Like I want to ask user to give two numbers, and then the program will show addition, subtraction, multiplication and division of those two numbers. So the question is how we are going to take the input. So in R we have one function read line. So this function will take a value from the user. So if I will execute this this particular instruction, it will wait for my input. So when I press some value, it will take that value. So at the moment we are not storing the value given by user. So let's say I will create one variable and I ask user to input a value. I input 12 and now the value 12 is stored in I. So I will try to see what's the type of this value. So the type of this value is character. So the thing is when you take input from the user using this function, doesn't matter what user is giving as an input, number, character, complex, it will consider everything as character and that value will be stored in the variable. And as far as this these operations are concerned, they can be only performed on numbers, on numeric type of value, and we cannot perform addition, subtraction, multiplication, division on character data type. So there has to be a way using which we can convert a character into the integer or other data type in numeric. So let me show you how we can do that. So I'm creating a variable just to show how to convert a number from its character representation to numeric representation. So there is a function as dot double, and here you can specify your number in character. So if I check the type of B is numeric, but if you check the type of 12 in quotes, so whenever you write anything in quotes, it becomes character. So the 12 in quotes is of a character type, but when you use this function as dot double, it converted this 12 from a character to double representation. So there are different types of numeric, for instance integer number or decimal number with single or double precision. So we are not going to go in depth here. So we just want to see how to convert a number from character to numeric, and we are going to use this one is as dot double. So now we will move to our script and we will replace 12 with red line and this one also red line. Now as we know, when we execute this function, user will give an input and that input will be stored in a character format. So A and B is storing value in character. So we need a way to change this value from character to numeric. So what we will do, I will use double. So by writing this instruction, I'm saying apply this function on A. So A is having at the moment character type of value. That value is converted into numeric, and then the numeric value is stored on A. And I will do the same for B. So now A and B storing numeric representation, numeric values. Save this script, and we will now execute this script. So now it's waiting for my input. I have given 23 and then 45.5. And now we got the response, we got the result: addition, subtraction, multiplication, and division. So here we are going to put one more change. When we execute this instruction, this script, it won't show anything like whether it is waiting for the user or not, or so it's a bit confusing. So here we will specify value for prompt. So it will be shown when when this particular instruction is executed. So enter first number, and here we will write prompt enter second number. Save this script and execute it again. So we are having one problem. So I have not specified the argument properly. So I have saved it again and source. So now it's a it's a bit better than the previous version. Now it's showing enter first number, so user can give first number, and then it is asking for another number, and then we are having the result. So in this script, what we did, we have taken two numbers as input from user, and then we perform addition, subtraction, multiplication, division, and then we printed those values. So now as we are done with our first R script, we will move to next step. So this part we have already covered, like taking numbers from user and then performing the same operations. And now we are going to write another script. So this script will take a number from the user as a radius of a circle, and then it will print the area of the circle. So just move to our R studio. We will create a new script. So let's create one variable, specify the radius, and then compute the area. So the value of pi is already available in R by writing this. So when you write pi, it will give you the value of pi. So pi r square. So either I can write r multiplied by r, or I can use exponent and I can write pi r square, and I will print the area. So I will save this script. Let's say second.r, and let me clear my console. And now I will execute this script simply by clicking on source. So the area is printed on our console. Now I will change it a bit. So instead of specifying the value of r here, we will take the value from user. So read line, enter radius, and then we will change the type of, A. So the first instruction, I'm taking an input from the user, and that input is stored in variable a. As we know, all input from readline function are stored as character type. The second instruction converts that character type into numeric and storing in another variable r. And then we are executing this instruction pi r square, and we are storing the result in another variable area. And here we have printed the value of area variable. So I will save it, and now I will execute it. So now it will ask me the radius, and let me specify something around something to 234, and it gave me the area. So we have written two very simple script, one to perform for arithmetic operation, addition, subtraction, multiplication, and division, and the second script to simply calculate the area of a circle where the radius is given by the user. So let's move further from here. So as the last topic of this session, I'm going to discuss vector. I will discuss how to create a vector, how to access element from the vector, and how to delete a vector. And the rest of the data structure will be discussed in the next sections. The next session, sorry. So when I say data structure, what I mean by that is a data can be arranged in different ways. So far we have seen different types of data, but now if I want to arrange that data, there are multiple ways, and in that direction the first type is vector, and we are going to see uh, what is vector and how to create it. So let's move to R Studio, and let's clear out the console. So what is a vector? So vector is a collection of elements of same type. For instance, if I am having a data of all character type, I can store them in a vector object. So when you have multiple data of same type, you can store them in a vector. So I'm going to create here the first vector. So how to create a vector? So the first way is using C function. So this instruction, if you start your instruction by hash, it means this is just a comment. This will not be executed by R. So I will create my first vector C, and here I will specify values. So let's say I want to store age of 5 student. So as you can see, all these are numbers. So vector stores multiple elements of same type. Uh, so in this particular example, we are storing multiple, but we can also create a vector with single data item. Now I want to see the class of this vector, and as you can see, it's numeric. It means all the data items stored in this vector are of numeric type. I want to find out how many number of items are stored in this vector. I can simply use this function length, and it will give me the number of items stored in vector v. Now let's create another vector with names. So I will use the function C. I will write John, Ravi, Mac, and I will see the class of names, and this vector is of type character. Now from the definition we know characters store all data items of same type But what will happen if we try to store data of different types? So let me create a vector. I will store some number and some name. So we did not get any error, but what actually happened, like in what type the all data are stored? So just see the class. So the thing is, everything is stored now as character, though we have a specified number, but this function actually converted those number into character, and then all the data types are stored as character. So these numbers are automatically converted into character. So C function actually maintain its property. It uh, store all item with the same type. So now we have seen how to create a vector with function C. There are other ways as well to create a vector, and in this direction I will use seq function. So this function, in this function you have to specify the start of your sequence. So let's say I want to generate a sequence from 1 to 100. So by default the sequence will be generated like 1 2 3. So the increase in the number is 1 by default, or we can see the step size is 1. But I don't want this default step size. I want to generate a sequence from 1 to 100, and I want a step size of 2. For instance, it should print 1 and then 3, then 5, then 7. Great. Now let's say I want to print even number between 1 to 100. So I will simply start my sequence from 2 and 100, and the step size 2. So it will be 2, 4, 6, 8, 10. Now let me store the result of the sequence in a variable. Sequence start from 1 and 2, and let me take a step size of 0.5. Now I want to count the number of items in Z. I will use length function. So I'm having 199 data items. I want to see the type of those items. So this vector Z is having data items of numeric data type. Now we will see accessing data item from vector. So how to access a particular data item from a vector? So when we create a vector, each data item stored on a index number, like its position number. For instance, if we look at our names vector where we stored various name, so we are having 5 names, and we can see this vector like, so the first name is stored as John, the second name Ravi, third Mac, fourth Pan, and fifth Jose. So I want to access the third name, so that here the third is index. So in order to access the third name in names, I will simply write the vector name and the bracket. So in bracket I have to specify the index, and I will write 3. So I have accessed data item stored on third index. Now let's say if I want to access more than one index, so how I want to how I will do that, I will write the name of the vector, then bracket, and here I have to write those index. Now I cannot write like this one, because in the bracket I have to write a single item, a single object. So what you have to do, you have to use vector here. So it might be a bit confusing. So for a time being, we will not focus on this one. We will go in more details in next sessions. Now, in my vector, let's say v, where I have stored the age of 5 student. So let me print the v. Instead of specifying index number like this one, I want to access, let's say, age from second student to fourth student. So what I can use here, second colon 4. So this is another way of generating a sequence. So it will generate a number like 2, 3, 4. And writing those number in bracket will access elements stored on those indexes. So let me show you the use of this operator. This is the another way of generating a vector. So if you can see here, this is a simpler version of seq function. So in seq function, you can specify the step size by which the number will increase. But here the by default step size is 1. So you can write the start, you can write the end, and it will generate a sequence starting from start to end, and with a step size 1. So if you want to generate a sequence with step size 1, you can either go for a colon operator, or you can use seq function. So we have seen how to create a vector using seq function, c function, colon operator. We have also seen how to access a particular item from the vector. So you can specify the index number, and then the item stored on that index number will be accessed. Now I'm showing you how to delete a vector. So I'm having a vector v. That vector has age of 5 students, and I want to delete it. So how to delete it? I will simply assign null. So here, if you can see, variable v is having value num1 to 5, and when I execute this instruction, all the data is gone. So we will explore a bit this function vector concept in more detail in next sessions. So coming back to our slide. So these are the ways we have seen. So I have not shown you how to create using rep function. That is for next session. We have seen how to count elements in vector, how to delete elements in vector. We simply assign null and all the elements in the vector are deleted. How to access element from vector. So thank you very much for watching. So in this session, we have seen the basics of R. So we have seen what are the different data types in R. We have seen basic arithmetic operators. We have written 2 script. So now we have the idea how to write simple script by taking input from the user. We have also discussed the first data structure available in R, which is vector. So we have discussed how to create a vector. So there are multiple ways. We have discussed. So in the next session, I will move towards control statement in R for instance, loop construct, if else, and then we will also talk about array and matrix data structure. Thank you very much for watching.